Okay, gentlemen, we're looking today at 7.2. It's our second lesson on trigonometry. And some of the things that we've learned in 7.1, as well as what we reviewed in the Get Ready handouts, will be useful here. So I've gone ahead and filled in the blanks for some of these answers. So similar triangles have the following properties. Well, first and foremost, they have angle measures that are equal. And the second thing is that corresponding side lengths are in the same ratio. All right, so let's take a look at the similar triangles that are given here. It says name a pair of similar triangles and show they're similar. Well, I can name a pair of similar triangles because I know there's two ways of proving this. Again, that angle measures equal or corresponding side lengths are in the same ratio. I prefer to use angles, so I know that this angle right here and this angle here are equal. How do I know that? Because if I look at this line that's parallel to that line, I have this transversal, and that tells me that angle ABC and angle DEC, which is basically these angles here and here, are equal because the F pattern creates this corresponding angle. So I know those two angles are equal, and I've written that there. And the easiest one to prove is the really angle C, because we've got two triangles, and both of those triangles, ABC and DEC, both have angle C there in common. So that the best way of just writing that is that angle C equal angle C common. And then we do need to define ABC as an angle. You have to write it that way, of course. ABC equal angle DEC corresponding or F pattern. You don't need to write both, just one. If F pattern is what sticks in your head, I'll accept that. However, if you want to use more sophisticated math language, of course, using corresponding is more proper, and I'd rather put that in my long-term memory if I were you. All right, so the first step here to remember is you always want to first show that the triangles are similar. You're proving it, and whatever proof you're using, you're going to make sure you write that beside in brackets. So I'm saying angle C equal angle C, and what's my proof? They're common. It's common to both the triangles. Okay, so once you've done that, the next very important step is right here. You want to say therefore the triangles are similar. You label triangle ABC, but you want to make sure when you label triangle ABC that you want to line up the next triangle, the second one, you want to line up angles together. We just proved that angle, this is parallel to this, and this is D and E. We know that this angle in here and this angle in here are the same, so I'm going to make sure that B and D line up with one another. All right, so when I label my triangles, I know triangle, sorry, not B and D. I think that's supposed to be E. That's what I meant. Angle B and angle E line up with one another. So you'll notice here when I wrote the triangles, B and E line up with one another. Of course, C lines up with C, and then the other two remaining are A and D, so they'll have no choice but to line up together. And what that helps us to do is this third setup, is writing the ratio of side lengths in the proper order. So AB, and you can see that here if I highlight it on this drawing I did on the side, AB would line up with DE. And then of course you have BC lining up with EC, which is right there. And then you have another one, we've got AC lining up with DC, and that makes sense. Okay, so that's why we've done that, and it takes the guesswork out of it later. If you do that properly, if you line up the triangles properly in step number 2, then step number 3 is a joke. You're just writing, then all you're doing is, I'll show you here, all you're doing is writing AB over DE, and that's what I have here. And then in the second step, you'll write BC over EC, and that's what I have here. And then you do the first and last AC over DC, and that's what we have here. So writing that in proper order allows you to do that very quickly. Okay, it says determine the value of x. So x is right over here. We want to find the value of that. Well, let me fill in what I know. I've determined here, I showed you here, I didn't highlight this in green because I don't know the length of BC, nor do I know the length of EC. I have no values for that. So really, as long as you have a numerator and a denominator and only one unknown, we can cross multiply and solve. And that's exactly what we do have here. So I'll show you by plugging in what we know. Do we know the length of AB? Yes, it's 5. And do we know the length of DE? We know the length of DE is 3. Oh, sorry, is 2. And then I'm going to use AC over DC. The length of AC, we don't know. I'm just going to call it AC. And then DC, we know is 3. We don't know the full length, but we know that from D to C is 3. And now I can cross multiply. I am going to erase this, if you don't mind, just to make some room for the calculation. And so now I'm going to use this, and I'm going to cross multiply. AC times 2 becomes 2 times line AC equal the 5 times the 3, which is 15. Divide both sides by 2. The entire length of AC is 7.5. Therefore, make it right here, therefore, we're looking for A to D. Length of AD is equal to 7.5 minus 3, which is 4.5, and that's when we input meters at the very end. So that has to be 4.5 meters because we determined that the entire side length of AC is 7.5 minus the 3, we've got 4.5. All right, here are your learning goals. The scale factor K relates the lengths of corresponding sides of similar figures, and all that says is that if I have this triangle here and I have a similar triangle and I have, let's say, ABC, and we'll call this DEF, but I know AC, if it has a scale factor of 5, that means DF is 5 times bigger. And then that means that BC would be multiplied by 5, and that would get me my length of EF. And AB multiplied by 5 would get me the length of DE. So each one of those is in the ratio of 5 or has a scale factor of 5. Also, the square of the scale factor relates the areas. The scale factor is known as K. So K squared relates the areas of two similar triangles. And we'll get into that in the seat work, and we'll review some of that in class together. I want to move on to the next question here. I'll do the first one, and I'm going to leave you with the second one. Because we were shown, here we're actually shown angle O is equal to angle J, and we're told here that angle M is equal to angle K. It's proven by the symbols given here, and of course angle N and L line up with one another as well. You'll see that just in the symbols in the diagram. I also pointed out in the question that the triangles in each pair are similar. The similarity does not have to be proven. We're told in the question that they're similar. So that saves us a lot of work. It saves us the first step of proving and showing some proof. So we can jump right to step 2. So first thing I want to do is just write my triangles. Triangle something is similar to triangle something else. So I'll call the first one JKL. Well, I know that J and O line up, again, because we're shown that here with the same symbol, and K lines up with M, so that would be M, and I'm only left with one other, which is N. So L and N have to line up with one another. Therefore, I'm going to write JK over OM is equal to KL over MN is equal to JL over ON. And then I can fill in what I know and cross multiply. And our corresponding sides work like this. We know that JK lines up with OM, and then we also know that JL lines up with ON, and then we also know that the other two, MN and JK, line up with one another as well. So JK has a length of 10, so I can write 10 over OM is labeled N. If you look in the diagram, that's labeled N. And KL we're given as J, and that would be over MN, and that has a length of 18. And JL, which is 8, and N or ON is equal to 12. And this is what's going to unlock it for us. Now I'm going to cross multiply. Did I write J over, that right? MN is 18. And let's see, ON is 12. And that's J. I think that's right. JK is 10. Okay, good. So 8 over 18. Okay, so now we're going to crisscross multiply here. And then I get 12J equal 8 times 18. Let's see, 8 times 18, 144 equals 144. Divide by 12, divide by 12, and of course J is equal to 12 because 12 times 12 is 144. But then we want to find 10n, so we're going to do find n. So we have 10 over n, and I can use the exact same ratio. I'm using that 8 over 12 as my key to unlock the scale factor. So we're going to cross multiply here as well. So I have 8n equal 120, and then divide both sides by, that's 120, divide both sides by 8, and it is equal to The 4 goes into, sorry, 4 goes into 12 3 times, so that's 30. 4 goes into there twice, so n is going to equal 15, and I forgot to label them meters. Yes, so that would be 15 meters. That's one answer, and this would also be meters here. Okay, I want you to look at this question here and do this one on your own. You're going to pretty much do what I did with the first one. You're given these two triangles. This one here is similar to this triangle here. That's already given to you in the question. You're told that. So you want to set that up and follow steps that I followed here, or follow steps basically 2 and 3 up above is what you're really doing. Okay, and we'll take that up in class together. Good luck with that.